to maximize or minimize something. So the first thing I want you to note is these steps here. I would recommend you just follow these steps. So if you have any sort of like geometry going on, like perimeter, volume, whatever, make sure you draw a picture and label it. Find the objective function. So like your objective is what you are trying to do. Are you trying to maximize something? Or are you trying to minimize something? Find what your restrictions are, and then you're going to substitute and then use the first or second derivative test. So use these, use your notes as you solve optimization problems and follow these steps until you know what the steps are without having to look. So a farmer has 2,400 feet of fencing, wants to fence off a rectangular field that borders a river. The riverside needs no fencing. What are the dimensions of the field with the largest area? So first thing you do, draw a picture. Okay. A rectangular field, it borders a river. So one side does not need fencing. So I'm going to label the other sides X and Y. So my objective is to what? Have the largest area. So we are trying to maximize area. I want to maximize area. And the area function is, well, what's the area of a rectangle? Just X times Y. So start with your objective. My objective is to maximize area. It's always going to be maximizing or minimizing if it's an optimization problem. So in this case, I'm trying to maximize area, so I write an area function. My restriction is how much fencing I have. I only have 2,400 feet of fencing. I don't have an infinite amount of fencing. So what's an equation to represent the amount of fencing? Well, you'll notice that my fencing is X, X, and Y. So 2X plus Y is equal to 2,400. That's my restriction. Okay. So you have your optimization function, your objective, you have your restriction function, and then step 4, substitution. So right now we have too many variables. We have A, we have X, and we have Y. So let's turn this A equation into just an equation with X's or just an equation with Y's. So what you can do is take your restriction function, solve for one of the variables. Here it's probably easier to solve for Y. So we get Y equals 2,400 minus 2X. Plug that into my area function. And then this is where we are going to use calculus to, again, what are we trying to do here? Maximize. So we need to find the maximum. Okay. So how do I find the maximum of a function? Okay, well, I've been practicing first and second derivative tests. So let's go ahead and find my candidates or candidate by finding the derivative. The derivative of A, we'll just call that A prime of X, is equal to 2,400 minus 4X. Critical points, set your derivative equal to 0 and solve. And you'll notice that I only have one candidate. Get negative 2,400 is equal to negative 4X divided by negative 4. I get X is equal to 600. Okay, so I do need to justify my answer. And this is required of any of these problems. You have to justify that you definitely have a maximum. So does X equal 600? Probably, but I still need to justify it using either the first or second derivative test. This is non-negotiable. You have to justify. So I'm going to use the second derivative test because I know that the second derivative is easy to find. The second derivative is negative 4. So what does this tell me? This negative second derivative means my function is concave down. And at X equals 600, I know that A prime is equal to 0. Is that enough to justify a maximum? Yes. So at X equals 600 feet, area is maximized because, and then my reasoning is A prime of 600 is equal to 0, and A double prime of 600, don't care about the actual number, just it's less than 0. Remember, if your second derivative is negative, your function is concave down. If your second derivative is positive, your function is concave up. Draw yourself a quick little sketch if you need to. So that's my justification. At x equals 600, area is maximized because blah, blah, blah. Okay, so then my dimensions, I just want to make sure I actually answer the question because the question says, what are the dimensions, not just what is one side. So the dimensions will be 600 feet by, and then to find the other one, just plug in 600. Y is equal to 2400 minus 1200, so that's going to be 1200 feet. And make sure you use units. So for these types of questions, you do need to write a justification using either the first or second derivative, and you need to make sure you answer the question with the correct units.